Good morning, 8th standard. Today we will do exercise 6.3, and before we start with the exercise, we are going to write down a definition. Since exercise 6.3 is based on calculating the square root of numbers, let us see what square root of a number means. The first thing we want to know is the square root operation is the opposite of square operation. Like for example, if you are solving an equation, if a number is being added, you transpose it to the other side, it becomes subtraction. Subtraction changes to addition. Same way, multiplication changes to division and division changes to multiplication when you transpose the operation from one side to the other. Same way, if you want to transpose square from one side to another, it will become square root. So, square root of any number, provided that it is a perfect square. So, we can calculate the square root if the number that we have been given is a perfect square. Otherwise, we will get approximate answer, not exact answer. So, square root of any number is another number which on squaring gives the given number. So, if you have been given any number, then you are looking for some other number, and that other number when squared will give you the answer as the number given in your question. Now this will be clear if we look at this example. Suppose we have to find out the square root of 81. So what I want is I'm looking for a number which on squaring gives me 81, and that number is 9. And that is what I have written. Square root of 81 is 9 because when we square 9, we get 81. Another example could be if I'm looking for the square root of, let us say, 144. So I want to find a number which on squaring gives me 144. If I'm able to find that number, that means I have obtained the square root of 144. So this is what square root means. Now the symbol for square root is this kind of symbol. This looks like division, but it is not division. These corners are sharp, not rounded like in division. So be careful when you use this symbol. You will get used to it. You just need a little practice. Now if I had to state simply, if x square equals to y, so this means if I square x, if I calculate the square of x, answer comes out to be y. This is what I've written. Square of x is y. On multiplying x with x, I get y. Then x equals to square root of y. So the opposite. This is what I said. This square operation has been transposed to the other side. And when it will be transposed to the other side, it will become square root. And this will be read as x is square root of y. So this is read as square root of y. Now if this doesn't make sense, this is how you can understand. 9 when squared gives 81 as the answer. So if I had to write it the other way, the square root of 81 is 9. Means where was 81 generated from? Which number on squaring gave you 81? And that number is 9. So this is what I have written. Square root of 81 is the number which on squaring gave you 81. And this is how we write down. There are 3 methods to find the square root of a number. The first one is repeated subtraction method, prime factorization method, division method. The repeated subtraction method is preferred for small numbers. So if you have large numbers, you want to use either prime factorization or a division method. And later on, it also depends on the question. You will come across some require the use of prime factorization and some require division method. And you have to be careful. There is a fact you want to remember, that when you calculate the square root of a number, there are 2 square roots. One is positive and the other is negative. But in this chapter, we will only be working with positive square root. Now, what does this mean? Let's take an example. If I write down the square of 2, so this is the square of 2, the answer will be 4. So, by definition, if the square of 2 is 4, that means 4's square root. That means square root of 4 is 2. Also, if you consider the square of minus 2, this will mean minus 2 is to be multiplied with minus 2 and the answer comes out to be 4. Same as what you obtained when you squared 2. Square of 2 is 4. Square of minus 2 is also 4. So this means, again by definition, because on squaring minus 2, the answer is 4. So what I can write down is square root of 4 is minus 2. So if I want to find out the square root of 4, I can give the answer as plus 2 or I can give the answer as minus 2, because if I square 2, the answer will be 4, and if I square minus 2, then also the answer will be 4. Both these numbers on squaring give the answer as 4. So if there are two numbers which on squaring give me 4, that means if I want to find out the square root of 4, there will be two answers. Both numbers which on squaring give me 4. So I would write square root of 4 equals to 2 or minus 2. But in this chapter, we are going to work with only positive answers. In higher classes, we like to consider both depending on the question. Let us do exercise 6.3. It's on page number 102, 103 of your textbook. The first question that we have is, what could be the possible ones digit of the square root of the following numbers? So you have been given some numbers. If you had to find the square root, now I am saying if you had to find out the square root, we are not going to find out the square root. If we had to, then in your answer, in your square root, what could be the possible ones digit? So you have to find out that what are the digits at ones place in the square root of the given number. I want you to compare this question with question number 1 of exercise 6.1. It was the opposite of this question. In question number 1 of exercise 6.1, you had to write down the ones digit in square of the number. So here we are doing the opposite. You can also refer to the properties discussed before exercise 6.1 before doing this question. The first part that we have is 9801. So simply stating, what we want to know is, if I find out the square root of 9801, means I will get an answer. I want to find out what will be the digit at the last place. This is what I want to find out. But I will not be doing it this way. I'm going to do it in the opposite order. I will look at the squares of the numbers which can give me answer ending with 1. I can also write this same mathematical relation this way. So there is a number which on squaring gives me the answer as 9801, and I want to find out the digit present here at the last place, the ones place. What is the digit here? And the number on squaring gives me 9801. So I will be only looking at the last digit because the last digit gives me the last digit over here. So which digit at the end on squaring will give me 1 at the end? So this is what I am looking for. Which digit over here on squaring will give me an answer ending with 1? So I could put it this way: which digit at ones place, at last place, on squaring will give 1 at the end in the answer. So for this you could go back to the table on page number 90, where you have been given a relation between the digit at ones place of a number and the digit at ones place in the square of that number. So refer to table on page 90. And you don't need to write all this in the exam. I will show you how to write your answer. To write down your answer, this is what you will do. There is a number, we don't have the number, which on squaring gives me 9801. So I want to know what is the digit present here. So I will write it as, you will start by looking at the ones digit in your answer. This is what I have written, the number given to me. What is the ones digit here? So the ones digit here is 1. I want to find out the digits which on squaring give an answer ending with 1. Now think of the numbers whose square ends with 1. Square of 1 ends with 1. If a number ends with 1, the square ends with 1. If a number ends with 9, then also the square will end with 1. So the answer here will be 1 or 9. If we had 1 here, on squaring, the answer will end with 1. If I had a 9 here, on squaring, the answer will end with 1, because on squaring 9 gives me 81, and at the end I will get 1. Looking at the second part, we have 99,856 now. Once again, I want to find a number which on squaring gives me this as my answer. But I'm not concerned with the whole number. I am only concerned with the digit at the ones place. So I start by looking at the ones digit in my answer. The ones digit in the answer is 6. So this is what I have written. So I am looking for the digits which on squaring give an answer ending with 6. So think of all the digits whose square ends with 6. So which digits have a square ending in 6? The digits 4 and 6. The square of 4 is 16, ends in 6, and the square of 6 is 36. That also ends in 6. So if we had 4 or 6 here, our answer will end with 6. Do the remaining 2 parts yourself. Now let's look at the second question. Without doing any calculations, find the numbers which are surely not perfect squares. So you have been given some numbers here. Out of these numbers, you have to pick those numbers about which you are sure that they are not perfect squares. I would like you to refer to the note we have written before exercise 6.1. Look at the 9th point. In that point, we have written by looking at the squares of various numbers an observation that if a number ends with 2, 3, 7, 8, the digits 2, 3, 7, 8 or odd number of zeros, that number will never be a perfect square. So you will be picking the numbers which end with the digits 2, 3, 7, 8 or a number which ends with odd number of zeros. So the answer is 153, 257, 408. These numbers are surely not perfect squares because these are ending with these digits. This ends with 3, this one ends with 7 and this one ends with 8. We are sure about the numbers which end with these digits, and if a number ends with odd number of zeros, those numbers are never perfect squares. And as far as a number ends with other digits, for example this one, the digits other than these, then we will have to check whether it is a perfect square or not by using the methods that we have. Question number 3. Find the square roots of 100 and 169 by method of repeated subtraction. Now, as the name of the method suggests, we will be doing subtraction repeatedly, but subtraction will come to an end. Based on that, we will give our answer. For this, I would like you to refer to property number 1 that we have written on 2nd May. In that property, we have learned that every perfect square can be written as the sum of odd numbers. And that is what we are going to use here. We are going to perform a repeated subtraction and we will subtract odd numbers starting from the first odd number, one by one. So the odd numbers are 1, 3, 5, 7, so on. So this is what we will do. One by one, we will keep on subtracting these numbers from 100 and then 169. And there will come a point when on subtraction, on continued subtraction, you will reach 0. And once you reach 0, then you will count the number of steps you had to perform to reach 0. And that will tell you what is the square root. The first part is 100. Let's start subtracting the odd numbers one by one. So 100, start with the number given. This is your given number. And then we subtract odd numbers. So this is 1, the first odd number. On subtraction, this gives me 99. So you start with given number and then you subtract the odd numbers one by one. Now your answer is 99. Let's take the answer now. 99 minus the next odd number. The next odd number is 3. Subtracting these two, I get 96. Now take your answer, 96. Subtract the next odd number, which is 5. The answer will be 91. Keep on going like this till you reach 0. Then I take 91, subtract the next odd. This gives me 84. Then 84 minus, after 7 the next odd is 9. This will give me 75. Now 75 minus the next odd, 11. This will give me 64. Take your answer, subtract the next odd, which is 13. You get 51. Then 51 minus the next odd, 15. This gives me 36. 36 minus the next odd, 17. This gives me 19. Now take your answer, 19 minus the next odd, which is 19. This gives me 0. I have reached 0. And this is where I stop. Once again, to use the repeated subtraction, you will be subtracting odd numbers one by one. You start with your given number, subtract the first odd number, you will get an answer. Then take this answer, subtract the next odd, you get 96. Then take 96, subtract the next odd, and keep doing this. Whatever answer you get, use it. Subtract the next odd number, you will get a new answer. Use that new answer, subtract the next odd number, you will get new answer. So going like this, you will reach 0 after a number of steps. And what we want to do is, we want to count how many steps we had to perform to reach 0. So let's count the number of steps. This is number 1, this is 2, this is 3, this is 4, 5, 6, 7, 8, 9 and 10. So I had to do the subtraction of 10 odd numbers. So 10 steps, and this is what the square root is. So therefore, the square root, I'm looking for the square root of 100. So this is what I'm writing down here. The square root of 100 is this answer, the number of steps. Remember, while using repeated subtraction, it is important that you reach 0. If you do not reach 0, that means you have made a mistake. Do the second part yourself for 169. Subtract odd numbers one by one till you reach 0. Once you have reached 0, count the number of steps, and the number of steps will give you the square root of 169. The rest of the work we will do the next time.